Lesson 3-8, Formulas for Linear Arithmetic Sequences. In an arithmetic sequence, what you have is a constant difference between your numbers. Therefore, you're able to write them in a certain way that you can see they are linear. The big idea is, as with other linear functions, 2 points on a graph of a sequence or 1 point on the graph and its constant difference are enough to determine an explicit formula. So as long as you know the first term in the sequence, as well as what it goes up by next, which is the constant difference, which is you could also determine as your slope, okay, it is enough to find your explicit formula. It says Demetrius is adding water to a fish tank 1 gallon at a time. The tank weighs 32 pounds when empty, and each gallon of water weighs 8.33 pounds. So 32 pounds would be what we started with, or pounds that we started with. And 8.33 pounds is how much each gallon of water weighs as you pour it in. So they got an equation, weight in grams equals 32 plus 8.33 G. Sorry, weight in gallons, my fault. Represent the weight of the tank after G gallons of water are added. Notice that this equation is in slope-intercept form, with the slope being 8.33 and the y-intercept of being 32. The increase of 8.33 pounds after each gallon is added is our constant difference between the terms of a sequence. In this case, the constant difference is a constant increase. Okay, very important to remember. Slope and constant difference, same thing. A sequence with a constant difference between successive terms is called a linear or arithmetic sequence. Because there is a constant difference between successive terms, a linear sequence is a linear function with the domain of a sequence. Okay, remember, domain of a sequence is your natural numbers. Okay, it's our counting numbers. Developing an explicit formula for an arithmetic sequence. The nth term of a sub n of an arithmetic linear sequence with first term a sub 1 and the constant difference d is given by the explicit formula, and you need to write this down. You need to pause it. You need to memorize this. A sub n is equal to a sub 1, which is the first term, plus the quantity n minus 1 times the difference, okay? The constant difference. What is it going up by or what is it going down by is how you find the explicit formula. So let's try one. Example 1 says, write an explicit formula for the arithmetic sequence 4, 7, 10, and 13. So the first thing we know, a sub n is equal to, because I'm just going to call this my arithmetic sequence, a sub n is equal to my first number, a sub 1. Okay? Remember, this is our explicit formula, a sub 1 plus the quantity n minus 1 times the common difference. All right? That's our explicit formula that I just showed you on the previous page. So my first term is 4, okay, plus n minus 1. And what's my common difference? My common difference is, what do these go? These go from 4 to 7, 7 to 10, 10 to 13, so they go up by 3. So my common difference is 3. If I do my math here, okay, distribute that through. 4 plus 3 times n is 3n. 3 times a negative 1 is a negative 3. I combine my like terms, and I get 3n. 4 minus 3 is 1. So my explicit formula for this problem is a sub n is equal to 3n plus 1. Well, B says compute the 30th term. Well, if I want the 30th term, a sub 30, all I do is put 30 in for n. 3 times 30 plus 1. Well, what's 3 times 30? 3 times 30 is 90, plus 1 is 91. So my 30th term is 91. Moving on. A recursive notation for an arithmetic sequence. The sequence defined by a recursive formula is, you state the first term, okay? And then it's a sub 1 is equal to the previous term plus d. For all integers, n has to be greater than or equal to 2. Okay? A sub 1 is the first term. Your constant difference is d. Okay? Let's try this one out. Very important to know. Please have this also written in your notes. Example 2 says, a cell phone company charges 25 cents per minute for overseas calls along with a 30 cents service charge. Okay? So automatically they're charging you 25 cents a minute. That means it's going up per minute at a constant at 25 cents. Along with a 30-cent service charge. So automatically once you make that call, it costs you 30 cents. Write a recursive formula for the arithmetic sequence that represents the cost of a call lasting n minutes. Okay? So we need to state the first term. Okay? So a of 1 equals, what happens when you make that phone call? You have a 30-cent service charge, and you're going to get billed for that first minute. So 30 cents plus 25 cents, as soon as you make that phone call, you're getting charged 55 cents right away. Okay? You're getting charged 25 cents a minute right after that. So a sub n is equal to my previous term, and sorry I'm running out of room, previous term a sub n minus 1, and what's my d? My d is it's going up by 25 cents. So plus 25, and then for integers, I apologize for running out of room, integers n is greater than or equal to 2. Okay? Now, can we graph the sequence? Sure. What you're going to see on that sequence is you're going to get a linear equation. Okay? And if you remember from before, yesterday's, I go to mode, I scroll down here, and I probably should clear my y equals before I do that. Okay. Hit zoom 6. Okay. But if I go to mode, I got to change my to sequence. Okay. Now I hit y equals. 1 is fine there. Previous term plus, what is it going up by? Well, it's going up by 25, okay, cents. We're not calling it 0.25, we're calling it just 25. So when we get our answer, it's all by cents. This is 55 cents. The next one's going to be 80 cents, right? Okay, so on and so forth. And my first term is 55, so we can graph this. And we're going to have to obviously make our window bigger. Okay. Go down here. And I need to make my window bigger. Let's just go 200. And go up by tens. Graph. But as you can see, it's a discrete set. It's not continuous. Okay. Because as soon as you start that second minute, it now costs you 80 cents. As soon as you, and if you go to my table, Okay? Your first minute costs you 55 cents. As soon as you start that second minute, it costs you 80 cents. As soon as you start that third minute, it costs you a minute or $1.05. Okay? You start the fourth minute, $1.30, so on and so forth. Okay? You don't have 3.5 minutes. They're not going to charge you 12.5 cents for a half a minute. You're automatically, as soon as you start that third minute, you're getting billed this. Okay? I hope that makes sense. Example 3 says, some car dealers offer interest-free loans. Those are great things, people. You don't want to have to pay interest if you don't have to. Provided that you pay back the amount borrowed by a certain date. Suppose a car that costs $14,736 requires monthly payments of $245.60. Let A of N be the amount that you still owe after N months. Okay? So, it says, A says, write a recursive formula for this sequence. Okay? When I write a recursive formula A, my first term, A sub 1, is I have my loan amount, but I have already made a payment. So I got to subtract $245.60. Okay? And if you do that on your calculator, you should get out $14,490.40. So that is actually my first term. $14,490.40. You got to kind of watch yourself here. Okay? And so my function, A of N, so I can say my sequence for every number afterwards, is the previous term. How do we say previous term? A sub N minus 1. And what is happening? Well, we are subtracting $245.60 every single month until it goes down to 0. So it's 4 integers. N has to be greater than or equal to 2. And yes, at some point in time that will stop. Okay? But you get the picture. For my explicit formula, remember that? Remember explicit formula. A sub N is equal to our first term plus N minus 1 times D. So my explicit formula for this is A sub N is equal to my first term, which is, what is my first term? My first term is $14,490.40 plus N minus 1 times D, and D is a negative 245.60. Okay? Why is this negative? Well, it's negative because we're going down. We don't owe more money. Okay? We don't owe more money. So, and I'm just going to make a little bit of room here. I should have wrote that underneath just to save myself room. I apologize for the amount of time this is taking. And I'll write it right down here. 4 integers. N is greater than or equal to 2. But I just want to show you this. Equals 14,490.4. Okay. This times N is plus a negative 245.6 N. Negative times negative is a positive, so plus 245.60. And what you're going to notice is, since I'm adding this, it takes me right back to my original amount, which is $14,736 minus plus a negative 245.6 N. And this is what it should look like. And why is this what it's supposed to look like is, well, this is the amount that I borrowed, and this is the amount, my slope, in which I am decreasing a payment every single month. Okay? So this is how a linear equation can be written in an explicit formula as well as in a recursive formula. That's all I have for you today. Please enjoy. We'll see you tomorrow.